Okay.
Alright, so this is gonna be fun.
Looks good to me.
Alright, we gotta home things first. So go to jog, rapid position, homing cycle. That's why you buy limiting switches. Alright, so now it's at its home, which is its original 0, 0, 0. You gotta reset it according to your stock material. So, we need to get over here quickly to do that. Rapid position. I'm gonna do back middle. And because I know it's not gonna hit. I didn't account for the 3D printed thing. Alright, you take over.
Okay, so what we have determined is the new origin needs to be at this point right here on my piece of stock, which is right there. So what Ben is doing right now is repositioning it using the coordinates here until he gets right there.
Alright, check it out. So we have different speeds at which we can traverse this landscape. You try not to run into your material. Foam's not going to really do anything, but hardwood you probably mess things up. Alright, so where we go to my X. You can also go to 0.1 mil to get it exactly. Alright, that looks good. Let me check my Y. Alright, so my X and Y are good. What I'll typically do is I'll zero that out, so on the screen set 0. So 0 my X, 0 my Y. The only thing isn't zeroed out is my Z right now. So done. Change it back to 1 mil. And where did we get that little piece of paper?
Oh, that's what I was looking for.
I got it. So this is how I find where my 0, 0 is at consistently. We'll do a millimeter first. If I can wiggle it, it ain't touching. There we go. So we were pretty close. Now I can set my 0, 0, 0. I'm gonna show you an extra approach that I didn't do yesterday. It's called doing a dry run. So I know that right now it's 0, 0, 0. I raised it +6. Let's go higher than that.
What are you doing now, Ben?
I'm gonna do a test run.
Okay.
Making sure that we're actually in the right place, because remember yesterday we cut through the material. It wasn't devastating, but a way to fix that is do a dry run above your piece, just to know it's gonna land in the right spots. And then come back, drop it 10, call it a day. All right, so I'm gonna call that 0, even though the real 0 is 10 millimeters below. 0 everything. I like to give my X, Y, and Z coordinates. Keep in mind, my Z's up 10, we'll fix that at the very end. So I'm gonna do another homing cycle. Waiting for it. All right, so these numbers are golden here. These numbers. Some 604.3, 335.2, and 8.6. So these, if I get lost, if I gotta change bits, if anything happens, I can come back to those numbers and know where in this three-dimensional space home is. So if you ever do want to do a bit change, you have to know these numbers, because getting right back to like 1/10 of a millimeter is not something a human does very easily. Let's see, I'm gonna jog. Okay. I'm gonna get it close and then show you a little, we'll call it a piece of code, we'll call it a little piece of G code on MDI, which is manual digital input. All right, so we're close. What I'm gonna do is MDI do G, capital G, 0x, 0y, 0z, 0. So this is gonna send it to the origin, slowly. Sorry, that's supposed to be G1.
Ooh.
G1. G1 is the conservative. I'm gonna jog it off through this point. All right, so it's away. MDI G1, X0, Y0, Z0. And you're gonna see it's gonna creep slowly into place. Slowly, but
Oh, it's going.
it's going. Keep in mind, I know that it's 10 millimeters above, but this lets me start the code without like any negative effects. So earlier on, you loaded the job, you went to your desktop, you found the NC file, which is the G-code file, computer. So right handle. This way I do my dating, the day, at what time during the day. Open it, and keep in mind, like, this is the computer, this is the brain of the operation. Those are just like the body. So you have to keep these things connected at all time. We got, yesterday we had 72,000. Today we have 1,900 lines of code. It seems like I missed something, but I'm pretty sure I didn't. I'd rather double check. Those three things, post-process, gerbil. I'm just gonna call this test. I just want to check the size. Test to desktop.
Yep. No errors.
No errors, which is nice. Go back into carbide. All right, so it's right. Today's code is more efficient than yesterday's code, I guess.
Sweet.
All right, so we're almost at the fun section. We don't have to cut this on yet because we're just making sure it runs in the right spots. The nice thing is, like, I start the process, it's gonna start just like a tenth and go, all right, you might want to insert the tool if you haven't already. You might want to turn the machine if you haven't already. So those are nice, I guess, safety errors.
Our kill switch.
Kill switch. You want the kill switch as close to you as possible in case you gotta kill it.
On, off. So if it starts cutting into the foam, we can kill it, or if it starts exploding.
It's not gonna keep it from sending code, but what it's gonna do is keep it kills all the motors. So important. So now we're gonna run it. It's gonna raise up, start the pass. I can also pause it. All right, so now we're watching.
We're making sure it does the outline.
Yep, we're making sure that when it cuts into the material, it's actually in the material. I don't think I need to kill switch this one because I'll be able to see the entire pass. In theory, it drops half the diameter of the bit, so it's going to drop, if that's a quarter, it's going to drop an eighth.
It looks like it's tracing out the profile pretty nice.
Yep. Sing to me, machine, sing to me. All right, however you fixed it to the board, is that going to be an issue?
That hole?
Yeah.
No.
All right,
This
cool.
is fine. Not worried. Alright, so, it's good.
Quit it. So now the dry run has been passed. This is where these numbers come in handy that we did earlier. I want to make sure it goes with the same. In theory, it should, but I like to know that things are actually sound. So we're going to run over here. Cool. Now I'm going to manually jog. Remember that 10 that we had earlier? All right, MDI, slow movement towards my original origin, good. Because the 10, I need to undo that 10. So I'm gonna go 1 millimeter on my move cutter. Seven, 9, 10. All right, so we're there. Set 0. If you don't do this, like, it doesn't know where to start. So this is the new origin. So there, everybody, that's the new home. Dunsky.
And that origin is set in Fusion before you export the file and post-process.
Yeah, a little reminder while we're in here. The origin's set during your setup. Here, so you set up a stock, but you need to figure out your XYZ first. Then you're gonna choose box stock point, which is a point on your stock, or in this case the phone. And you get to choose the point at which you want to start it. So we picked, let's give you all the options. You get all these options. We do that one. And this is me running it. I might choose that piece because I think this part's going to be cut as we're routing our piece. And if I needed to come back and rehome it on this dot, that could be a problem. The nice thing is we have the numbers, we have the origin. So good news on that. Let's run something, yeah?
All right.
Card by cut, load, handle, open, run, same file we just loaded. Kill switch at the ready. There is an equation online where you can figure out according to what material and your feeds and speeds how fast to run this, but because we're doing foam, I don't have to be that particular. Eventually when you do harder stuff, we try to make the bit last as long, so the rate at which it goes to the material and the rate that it spins needs to be worked out, but we're not to that point yet. All right, play button. Are you running this thing? No, but we will be. And foam, especially MDF, it gets nasty, so. Project running. So that's good, that's about an 1/8 inch down. That's a good depth. When you run the simulation, it's gonna take around 40, 45 minutes total cut.
Yeah.